Hello my dear PU1 students, welcome to Deeksha Karnataka YouTube channel, and today I am going to discuss all the important questions of 2 and 3 markers for your PU1 final exam. So if you have not prepared and wondering what all you have to study, so I am going to discuss very important 50 questions today, and if you study those 50 questions, all the 2 and 3 marker questions will be covered. Remember that you are going to require to answer at least 5 2 marker and 5 3 marker, so total 10 questions you have to attempt, and 50 questions is obviously a small number of questions that I am going to discuss right now. Based on obviously all the colleges, all the institutes are there, so they will make their own questions, so it is very difficult to exactly predict what are the questions will come. So I have decided that I will discuss all important questions. So if you stay with me, if you stay till the end, definitely it will be helpful for you for your final exam. Okay, so even if you have not studied and you are wondering what my teachers will say, what my parents will say, then tell them that Soumik Sir is here and he will help us to pass in the exam. Not only pass, he will also help us to score 60 plus marks, right? So let us start. First question. So we are not discussing overall chapter wise, but we will try to follow as much chapter sequence is there in your textbook. So in some cases there will be some overlap, so please ignore that if you are thinking that I will be discussing chapter wise. So purposefully I have not decided to discuss the questions chapter wise, because in your exam there will be no chapter wise question. Okay, it will come randomly. So let's start. Give any two limitations of dimensional method. It can so dimensional methods limitation, very interesting question. It cannot determine the values of numerical or dimensionless constants in equations. For example, a number such as half, pi, or small e, exponential e, that appear in many physical formulas cannot be found using dimensional analysis, right? For example, time period of a simple pendulum is given by t equals to 2 pi square root of L upon G. So L, this formula can be calculated, this square root of L by G, but this constant 2 pi cannot be calculated using dimensional analysis. Okay, we will see that. We have a question where we have to determine this equation, and 2 pi constant generally does not come from dimensional analysis. It cannot be applied to formulas containing trigonometric, exponential or logarithmic function. This method is only works for equations that are algebraic and consists of product of ratios of power of quantities with dimension. For example, suppose I say A equals to sine x. For example, this equation cannot be derived using dimensional analysis method. Okay, so if it is an algebraic relation means simple A x to the power A equals to b x to the power of b. Suppose algebraic equation means a x to the power of small a plus b x to the power of b equals to c z to the power of c. So this kind of equation can be not even addition has some limitation, but anyway, so this kind of equations can be checked or derived using dimensional analysis, but if it is like this, it cannot be determined using dimensional analysis method. So dimensional analysis is the method through which you can determine whether the equation is true or false. Secondly, you can also determine the exact formula. Okay, if you know what are all the variables and their respective dimensions, you can even find the formula as well, right? Now next question, state the principle of homogeneity of dimension. Okay, so this is very important question, principle of homogeneity in case of dimensions. The principle of, generally it's a 2 marker question. The principle of homogeneity of dimensions states that all terms in a physical equation must have the same dimensions, that is, the dimension on both sides of an equation and in every term must be identical for equation to be physically meaningful. For example, if I say A equals to B plus C, that means the dimension on the left hand side and right hand side should be same. There is no doubt about it. Not only that, dimension of A should be equals to dimension of B, and that should be also equals to dimension of C. Individually also their dimension must be same. Okay, so this is the condition of homogeneity, the principle of homogeneity in case of dimension. Okay, write any 2 or 3 rules for writing a significant figure. This is also very common important question. All non-zero digits are significant. For example, the number 4, 5, 6, all digits 4, 5 and 6 are significant. Okay, so 456 is a number, and in that number all numbers are significant. Zeros between non-zero digits are significant. For example, 4005, okay, 4005. So all 4 digits 4, 0, 0 and 5 are significant. This is called sandwiched rule. So if 0 is sandwiched between 2 non-zero number, then all zeros are significant. Trailing zeros in a number with a decimal point are significant. Very, very important. So if there is a decimal point is there, no matter whether it's a 0 or non-zero, it is a significant figure. So 50.00 has 4 significant figures. This is very interesting because sometimes you might see a question, MCQ question based on this principle as well. So they will say how many significant figures are there in 50.00. So if there is a decimal, then all zeros are significant. It only shows the placeholder, and the zeros are always significant. Check the dimensional correctness of the equation x equals to v naught t plus half at square, where the symbols have their usual meaning. So x is displacement. Okay, so first we will this has to be done in left hand side and right hand side, also using equation of dimensional homogeneity of dimension principle. So if A equals to B plus C, as I mentioned, okay, the dimension of A must be equals to dimension of B, and that should also be equals to dimension of C. So if you see that here, this is x, that is A, this term is B, and this term is C. Now here half is a constant, so we ignore half, the term half. Okay, so what is the dimension of x? Dimension of x is x is only distance. It represents position or displacement. Okay, so x is distance, so its dimension will be m to the power of 0, l to the power of 0, l to the power of 1, l to the power of 1 displacement, right, or distance. Distance means only l should have 1, time should also be 0. Okay, so m to the power of 0, l to the power of 1, t to the power of 0. Now we will find the dimension of this term v naught t. Okay, dimension is represented using this third bracket. Okay, the third bracket is basically means it is the dimension. Okay, so what is the dimension of velocity? Velocity means what? Velocity means distance traveled per unit time. Okay, distance traveled per unit time, you have learned it in the smaller classes where you used to do speed time problems, right, in mathematics. Also in physics class, in class 9th, I guess you also have done some problems on this, right? So velocity means distance traveled per unit time. So if you are someone who are very if you feel that the dimension is a difficult quantity to remember, then one thing you can do is to remember the units, which is much easier because you are using it for a long time. So what is velocity? Velocity is distance traveled per unit time. That means its unit is meter per second. Meter per second. Now what is meter? Meter is a length. Meter means length. So basically that means length to the power of 1, and divided by second. Second is what? Second is time, but it is in division, so its dimension will be L to the power of 1, T to the power of minus 1. Now there is no M involved, so M should be power 0. If nothing is involved, we have to write in for the sake of explaining the dimension properly, so it will be M to the power of 0. Now let's see. So dimension of velocity we have calculated, m to the power of 0, l to the power of 1, t to the power of minus 1. Now what about this t? T is time. Time means second. What is the dimension of time? Dimension of time is nothing but m to the power of 0, L to the power of 0, T to the power of 1. Very simple, right? Now add them. Now when you are solving a question like this, try to mention the quantities which are also not present in that quantity. Okay, this is the proper way of solving dimension analysis based question. Okay, even if m is not there, you have to write it. Okay, so don't skip it. Now it will be equals to m to the power of 0, L to the power of 1 plus 0, that is 1, and T to the power of minus 1 plus 1. Minus 1 plus 1 means 0. So we see that the dimension of V0t is also same as x. Now what about dimension of AT square? Half we will ignore, as I mentioned, this is a constant. So dimension analysis cannot determine the constants. But AT square is a quantity, so we have to find the dimension for AT square as well. What is A? A is acceleration. A is acceleration. You will learn more about acceleration in some other next chapter. But acceleration means rate of change of velocity. Rate of change of velocity with time. You have studied in 9th class as well. So rate of change of velocity is called acceleration. So velocity is meter per second, and if you divide it by 1 more second, you get acceleration. So what is the unit of acceleration? Unit of acceleration is meter per second square. Per means division. Now what is meter? Meter is again L to the power of 1 and divided by second square, so T to the power of minus 2. No n involved, so m to the power 0. Okay, so now you have to write the entire term for A. So m to the power of 0, L to the power of 1, T to the power of minus 2. Remember the process, you have to solve it exactly the way I am showing. What about T square? T square is again only time. So m to the power of 0, L to the power of 0, T to the power of 2. Square is there, right? Time square. So dimension will also be squared. Now you again add them all. So because it's a multiplication, so m to the power of 0 into m to the power of 0 is obviously m to the power of 0, right? L to the power of 1 into L to the power of 0 is L to the power of 1. Power gets added, right? When you multiply two quantities, power gets added. So 1 plus 0 is 1. T minus 2 plus 2. Minus 2 plus 2 is T to the power of 0. So if you see that, so dimension of x is equals to dimension of V0 t, and that is also equals to dimension of AT square. So the equation is dimensionally valid. You have to write the equation is dimensionally valid. Don't forget to write that. Okay, so the equation is dimensionally valid. So this is how you should solve. Very careful. If in case you forget a dimension, they will change the quantity. Maybe they will give you a new equation. But remember that if you forget the dimension, try to understand what quantity it is and what is its unit. If you know the unit, your 90% problem is solved, because from the unit you can easily write the dimension, and then you have to check whether it is correct or not. In case suppose you find that one dimension is not matching, then you will say that this equation is dimensionally not valid. Now next, derive the expression for period of simple pendulum which depends on its length and acceleration due to gravity g using dimensional analysis. Now as you see that time period, how it is dependent is not given, but it is said that it is dependent on length L and acceleration g. So time period is generally represented by capital T. This is not the dimension of t, this is capital T, time period. Time period is dependent on length. How it is dependent? Not given, so we will say it is dependent on L as L to the power of A. Okay, A is an parameter. A is a parameter. Parameter means a number. Okay. Parameter means it's a variable number. It can be any value. okay, and T is also dependent on acceleration due to gravity, so it will be T to the power of B. A and B may be same, may not be same, we do not know, so B is also a parameter. Okay, now you have to find the value of these two parameters for this particular given case. Okay, now for that what you have to do, so if A is proportional to B, A is proportional to C, then we can write A is proportional to B into C, or A equals to constant K into B into C, KBC, कौन बनेगा करोड़पति, right? So you can write it like this. So here what we will be doing, we will write the same thing. So T is proportional to L to the power of A, G to the power of B, or T is equals to the constant K, L to the power of A, G to the power of B. Okay, here K is a constant. K is a constant. We are not super enthusiastic about the value of K, but we are more interested in value of A and B. Okay, now what we will be doing, what we have to again apply the condition of dimension, and we have to write the dimension on both sides. Okay, so what is the dimension of taking dimensions? You have to write taking dimension. So what is the dimension of T? T is time period. So now as the name suggests, the time period's dimension is also T. Okay, so we will write m to the power of 0, L to the power of 0, T to the power of 1. Because it's only time period, only one time is there. So one time means T to the power of 1. K is a constant and it's a dimensionless constant. So K is a constant, also you have to mention dimensionless. Okay, I forgot to mention it. So dimensionless means K's dimension is not included in here, so you can ignore it. Now what about the dimension of L? L is length. L is length. Length means obviously M is 0, L is 1, and time is 0 as well, to the power of A. Okay, so whole to the power of A. What about this quantity G? G is gravitational acceleration. So whether it's a gravitational acceleration or normal acceleration does not matter for dimension. Dimension is same for gravitational acceleration as well as normal acceleration. So what is the dimension of acceleration? M, L to the power of 1, T to the power of minus 2. Okay, dimension of acceleration we explained in the previous part. Now you have to simplify this. Now take this A inside, so m to the power of 0 into A becomes m to the power of 0, L to the power of A, T to the power of 0. 0 into A is still 0, right? Similarly for B it will be m to the power of 0, L to the power of B, T to the power of minus 2B. Okay, now you have to add these. These are getting multiplied. Multiplied means power is getting added. So if you multiply two quantities, their power is getting added. So x into x is x square, right? X to the power of 1 into x to the power of 1. So power gets added, so it will be x square. So now m to the power of 0, L to the power of A plus B. And what we get? T to the power of 0 minus 2b, so it will be T to the power of minus 2b. So this much part is done. Now as I mentioned, the dimension of both sides should be same. So m to the power of 0, n to the power of 0 is matching, no worries. On our left hand side we have L to the power of 0, but on our right hand side we have A plus B. So from dimension we can say that A plus B must be equals to 0, right? On our left hand side we have power 0, on our right hand side we have A plus B. So if dimensions are matching, then A plus B must be equals to 0. Left hand side, right hand side should be same. So from here we say A equals to minus B. A equals to minus B. Now comparing the dimension of L, comparing L. Next comparing T. So now if you compare the dimension of t on both sides, on our left hand side we have t to the power of 1, on our right hand side we have t to the power of minus 2b. Okay, so 1 and minus 2b must be equal, so 1 must be equals to minus 2b, or b must be equals to minus half. So if b is minus half, what is the value of a? So from there we can say a must be equals to minus of minus half, that is half. So a is calculated, b is calculated. Now we can go back to our equation over here and we can say time period t is equals to this constant L to the power of half and g to the power of minus half. Now you can leave your answer over here, you will get full marks, but to the power half has a special term. So if I say x to the power of half, that means it is square root of x. Okay, and if I say x to the power of minus half, then it is 1 by root x, right? Minus power minus means it is actually in division, right? So from all this concept, what we can write is the actual formula for this time period. T is equals to k square root of L up by g. This is the exact formula. Now from this equation k value cannot be determined, but we know from experiment that the value of k is 2 pi. Now you do not need to show that in here. Okay, so this is how you should do the derivation. So first step is to write the equation. This exact step you have to write. Sometimes the same question can be asked as a 5-marker long type derivation question. If the teacher thinks that okay, this is a 5-mark worth question, so they might give you a 5-mark question as well. Generally it is a 3-mark question. Now let's move on to the next question, but before moving on, I just wanted to remind you that if you want to download the PDF of this lecture and any other future lecture that is happening in our channel, then you have to join our WhatsApp community. WhatsApp channel link is given in the description section of this video. All 1-marker videos that I have done in our channel, and this video, and all the future 5-marker and other videos that we are going to do, that will be available. The PDF of that will be available exclusively in our WhatsApp channel, so don't forget to join our WhatsApp channel. Link of that is given in the description section of this video. Also, if you are watching this video for the first time in our channel, or maybe you have watched in the past as well but you have not subscribed to our channel, then don't forget to subscribe to our channel. So subscription and joining the WhatsApp channel, these two are very, very essential for us, so don't forget to subscribe, and obviously if you like our content, don't forget to like this video as well. Now let us look into this question. Write any two difference between instantaneous speed and instantaneous velocity. Okay, so instantaneous speed, what is instantaneous speed? It is the magnitude of how fast an object is moving at a particular moment without any regards to its direction. In instantaneous velocity, it is the same thing, but change in speed as well as direction. So basically what we are doing, we are defining the speed and we are using this speed concept in the second definition, and we are adding the direction. Okay, so how fast an object is moving without any direction is instantaneous speed, and how fast an object is moving along with this direction in which it is changing is called instantaneous velocity. So this is a scalar quantity, this is a vector quantity. So simple. Let's move on. Draw a position time graph for a body moving in positive direction with negative acceleration, positive accelerations, constant speed. So this any 1, 2 or all 3 might come, so be prepared for this. So position time graph for positive acceleration is negative acceleration is decreasing, the speed is decreasing, so the position time graph will be like a parabola, but parabola with the axis like this. Position time graph for positive acceleration, it will be again a parabola, but it is increasing, and constant speed. So this is constant, not acceleration, it is constant speed. So constant speed, the graph is a straight line passing through the origin. Okay, basically we are assuming in all 3 cases the initial speed is equals to 0. Okay, we are assuming initial speed is 0 for all 3 cases, right? Now let's move on. A body, and you will get the PDF from our WhatsApp channel, so don't forget to join. a body moving with an initial velocity 5 meter per second and uniform acceleration of 1 meter per second square, determine its velocity after 20 seconds. You might feel that it's a numerical, very difficult. Actually, this is an easy numerical. 2-3 marker numericals are very easy, and scoring, even if you are not writing too much, if you know the formula, if you know the equation, you can solve it. So the equation is very, very simple. V equals to V naught plus AT. Okay, speed is initial velocity plus A into T. A is acceleration. Here V naught is given by 5 meter per second. Now some of you might be using U plus AT, that is also fine. In your textbook throughout V naught is used, that's why I'm using V naught. Okay, and uniform acceleration is given by 1 meter per second. 1 meter per second. Okay, so acceleration is given by 1 meter per second. What about, what else? Time after 20 seconds, that means T equals to 20. T equals to 20 seconds. Now we will use this equation and put all the values. So V equals to 5 plus, so V equals to 5 plus 1 into 20. As simple as that. So 25 meter per second. Only thing that you have to be careful about the unit. So when you are solving a numerical question, make sure you are using the unit. Now next, derive the expression of V is equal to V naught plus AT using velocity time graph. This is not the long derivation that you may have practiced. This is the short derivation. Only 2 marker, maybe 3 marker question will come. So here the diagram is same. You are drawing x-axis, along x-axis you are x-axis you are plotting time, along y-axis you are plotting velocity, and velocity, initial velocity is V naught, and suddenly it changed with an acceleration, so it is uniform acceleration. Now uniform acceleration means if you can calculate the slope of this graph, okay, that is slope is given by, what is slope? Straight line. If you have studied straight line, you know that slope is basically tan theta, but we are not using tan theta. It is delta y by delta x. That formula we will be using. Okay. Now the slope of this graph will be m equals to acceleration. Slope of a velocity time graph gives you the acceleration. Okay, so if you can calculate the slope, if you know this angle theta, and if you can calculate tan theta, that is this. Okay, you this one you can also calculate using trigonometry. Okay, in trigonometry tan theta is perpendicular by base, so using that also you can calculate. Okay, anyway, so tan theta or slope is acceleration in a velocity time graph. So in a velocity time graph, slope is actually equals to acceleration. This information you need. Okay, so acceleration will be change delta v by delta t. Okay, so what is delta v over here? Delta v is this one. Okay, so this is the triangle that we are considering, right? This is the triangle that we are considering. So for this triangle, this is delta v. So delta v is v minus v naught. So it is v minus v naught. And what is delta t? Delta t, suppose this time is t. So this time is t. So that means delta t is simply t. Now you have to organize it. Okay, so just you have to mention slope is equal to acceleration. Only one line remaining is just simple pure calculation. So a into t equals to v minus v naught, or v equals to v naught plus at. Okay, simple derivation. Now let's move on. Mention 3 applications of velocity time graph. So calculating the acceleration, the slope of a velocity time graph gives the acceleration of the body. A steeper slope indicates greater acceleration, while horizontal line means no acceleration. Determine the displacement. Area under the velocity time graph between 2 time intervals represents the displacement of the body during that time. Analyzing the motion changes. Velocity time graph helps in visually identifying changes in the motion, such as when an object speeds up or slows down or it comes to a constant velocity. So velocity time graph gives you an idea about you can calculate acceleration, you can calculate the distance traveled, you can also understand that how fast it was moving, suddenly it slowed down or not, so that all information can be taken from velocity time graph. Write the expression for resultant of two concurrent vectors A and B and explain the terms. So here we have two concurrent vectors, say A and B, and you are trying to find its resultant. Okay, so resultant means suppose this is A, this is B. Only resultant is required, not the angle. So the angle between them is theta. So the resultant is given by, okay, resultant means angle has to be there. Okay, so it will be A square plus B square plus 2AB cos theta, and the angle, so the resultant vector, suppose the resultant vector is along this direction. So this angle, say, is phi. So tan phi equals to A sin theta divided by B plus A cos theta. Okay, so this is the tan phi, this is the resultant of the vector. You only have to mention that theta is the angle between the terms, angle between the vectors. And phi is the angle between R and B. Okay, remember the angle with which you are measuring, okay, that will come in the division as a single term. Remaining A will be coming as sine as well as cos. Now let's move on. Two vectors of same units have magnitude 10 and 15 units. What are the maximum and minimum magnitude of the resultant that can be obtained from these two vectors? Very common question. Exactly 10 and 15 may not come. It can be 11 and 16. It can be 5 and 9. So the values can be changed. But the question pattern is very common. So here you have to identify the maximum and minimum vectors from these two vectors. Okay, so maximum vector, maximum magnitude, okay, only magnitude, direction is not required. So maximum is possible when both vectors are in the same direction. If both vectors are in the same direction, then the magnitude is maximum. So maximum will be 10 plus 15, that is 25. Okay, now what is the magnitude? Now magnitude does not take any sign, so you can use positive only. Now what is the minimum? Minimum is possible when one is in this direction, another one is in the opposite direction. If the vectors are in opposite direction, then the minimum magnitude occurs, and that will be 15 minus 10, that is 5. Again 10 minus 15 does not matter because its magnitude, so sign will be always positive. Okay, so maximum is addition, minimum is subtraction, larger minus smaller. Okay, clear? Next, derive the expression for time taken to reach maximum height by a projectile. So suppose you have thrown a projectile. This is a small derivation. Okay, this is not the show that trajectory of a projectile is parabola or calculate the range, etc. Okay, that is, those are generally 5 marker question. But here we have projected a projectile, say velocity v. This angle is theta. Okay, so this is the v cos theta term, and this is v sin theta term. Right? So this is how a projectile is drawn. Okay, this is a part of a parabola, and this angle is adjacent. So adjacent angle is cos theta, and perpendicular angle is sin theta. Now what you have to find is the maximum height, time taken to reach the maximum height. So you have to find the time taken to reach the maximum height. You don't need to find the time of flight. Time of flight can also be calculated just with one more step. Time of flight can also be calculated. Same question can be asked with the time of flight. Okay, but you don't need to calculate the height, you need to calculate the time. You have to calculate the time, not the height. Height equation calculation etc. are 5-marker question. Okay, now what you have to do over here? So first of all, if you throw a projectile, gains height only because of this component, that is the vertical component. Okay, in the vertical direction there is one more force that is acting, that is the gravitation, and because of gravitation the object starts to decelerate. Okay, when it is initially started to move, the gravity will try to pull it back, and because of that it will slowly slow down in the vertical direction. It is same as if you are throwing something up and it is falling back. Okay, so if you throw something back, what will happen? It will go up and then it will stop at the maximum height, then it will come back. Similarly, if you ignore the horizontal motion, it is basically happening that, okay, it is going up, stopping, and it is falling back. Okay, so that time that we have to calculate the time up to which it rose to the maximum height. Okay, so at maximum height, at this position, this velocity is still there, but that velocity is 0. So the horizontal velocity is still there, but vertical velocity is 0. Okay, so this component becomes 0. Okay, so initially the velocity was v sin theta, final velocity is 0, and what time it required, that we have to calculate. Gravitational acceleration is z. So we know that v equals to v naught plus at. This simple equation that we are going to use is this. Now v is the final velocity, that is equals to 0. V naught here is v sin theta, so that will be v sin theta, and acceleration here is minus g. Why minus? Because the velocity is in this direction, acceleration in the opposite direction, so their sign has to be minus. Time t that we are trying to calculate, so we get 0 equals to v sin theta minus gt, or t equals to v sin theta upon g. So this is the time that it raise. Okay, so this is the time to reach maximum height. Okay, what about time of flight? Time of flight is actually nothing but 2t. Time of flight. Time of flight is the total time to reach from this end to this end. The total time is time of flight, and that is given by simply 2t. So don't be afraid if you see, oh sir, I have only practiced the time to reach the maximum height, but in my exam the teacher asked me time of flight and I don't know how to do that. Nothing, you have to just multiply by 2, nothing else. The derivation is same, process is same. You have to write that at the maximum position velocity is 0, the vertical velocity is 0. So that means for vertical component of velocity, for vertical component of velocity, this is the formula. Now next, what is meant by range of a projectile? Give the expression for the same. What is the angle of projection for which the range of projectile is maximum? The range of a projectile is the horizontal distance it covers from the point of projection to the point where it lands on the same horizontal level. The range is given by u square sine 2 theta by g, u square or v square, whatever symbol you are using. Okay, the range is maximum for theta equals to 45 degrees. Okay, so maximum range is 45 degree. Range is the max distance from the starting point and ending point, horizontal distance. Okay, and range formula is u square sine 2 theta by g. Next, explain the triangle method of vector addition. Now, triangle method is most common and most asked. I am only discussing triangle method. If you get time, you should also study the rectangular method, parallelogram method as well. Okay, parallelogram method generally not asked very often. Triangle method is more common. So, if I have students from 10 different colleges and if they are asked the question about vector addition, suppose 5 of them are given a question on vector addition, then 3 of them will be given triangle method, 2 of them will be given parallelogram method. Okay, so more students are going to get vector addition rather than triangle method rather than parallelogram method. So parallelogram method I am not discussing. If you get time, you should study that as well. The triangle method of vector addition is a graphical way to add 2 vectors by placing them head to tail in sequence. Draw the first vector with its tail starting at the starting point. So we will start the vector like this, starting point. Tail means the starting point, okay, end point, okay. So tail at the starting point. Draw the second vector from the head. Second vector from the head of the first vector, that is tip of the first vector. The resultant vector is the side of the triangle that connects the tail of the first vector to the head of the second vector. So this gives the resultant vector. Okay, diagram is compulsory if you are being asked about triangle method or rectangular method. Okay, resultant formula is same. We have already seen that, so you don't need to write the resultant formula. Next, mention any 3 advantages of friction. Helps in movement. Friction allows us to walk, run, drive vehicles without stopping, without slipping. Without it, we would just slide around. So if there was no friction, I would not be able to walk on this surface. Okay, I would just slip. Friction helps in stopping. The braking system of an automobile use kinetic friction to stop motion, the brake that you apply. Next, enables gripping and holding objects. Friction between our hands and the object helps us to hold things securely like a pen or a cup. So if there was no friction, there would be no exam because you will not be able to hold your pen. Okay, some of us while writing exam, our hand sweats and our pen slips in the exam hall because the friction reduces with the sweating, right? Now next, what is an impulsive force? Give example. An impulsive force is a force that acts on a body for a very short duration, but it is extremely large in magnitude. Despite acting for a just brief moment, it produces a significant change in the body's momentum. Hammering a nail. When hammer strikes a nail, a large force is applied in a brief instant, driving the nail into the wood or wall. So if you hammer a nail, don't hit in your hand. Okay, when you are hammering a nail, okay, what happens? The force of the hammer is large and it acts for a very small duration. You are hammered for a few seconds only, and that is sufficient for the nail to go inside. Another thing that we all love to see, Virat Kohli played a beautiful cover drive. Now why it is possible? Because of the impulsive force. So batting in cricket, when a batsman hits a ball, the bat exerts a huge force in a very short timeline, rapidly changing the ball speed and direction. So when Virat Kohli hits a cover drive or Hitman Sharma hits a pull, okay, the ball hits the bat for a very brief amount of time, and the power that they exert on the ball, that power carries the ball outside the boundary. Right? Now you know why our batsmen we call timing. Okay, you may have heard the term timing the ball. Why timing the ball? Because if you hit it at the correct time with the correct amount of force, the ball will reach the boundary. Right? So it is basically an impulsive force. What is banking of roads? Why banking is necessary for curved roads? So banking of a road, banking means when you are traveling on a curved road, you might see that the road is not flat, it is slightly curved. Suppose you are traveling on a road, okay, this is the road. So the road is not very flat, it's slightly curved inward, okay. So why it is so? Is it for design only? or it has some other purpose. So banking of road is the process of raising the outer edge of a curved road above the inner edge. So when you are moving, the side is slightly curved, the outer edge is slightly curved than the inner edge. It is quite visible when you travel in a highway where cars and vehicles are moving at a high speed. Okay, creating an incline at a specific angle. So incline means this is incline, okay, at specific angle. Angle is also specified based on the material used in the road. This inclined surface is designed so that when a vehicle negotiates the curve, the normal friction from the road surface has a component that acts towards the center of the circle, providing the necessary centripetal force for circular motion. So whenever you are moving in a circular motion, there is a force necessary for you to rotate. That force is called centripetal force. Centripetal force is necessary when you are moving in a circular motion. Okay, and if we can break our own weight is already there. So if we can break our own weight as a component, and that component supports the motion, then that will be more beneficial for us, and we can avoid major accidents, and that's why the road is basically curved at the outer edges. Now, state and explain Newton's second law of motion. Define SI unit of force. Very common old question. The rate of change of momentum for a body is directly proportional to the applied force and occurs in the direction of the force. This is the statement. Statement you have to remember. Next, mathematically, father equals to ma, F equals to ma, where F is force applied, m is mass of the object, and a is acceleration due to acceleration of the object. The SI unit of force is Newton. Definition: 1 Newton is the force required to accelerate and 1 kg mass by 1 meter per second square. Okay, so these all things are very important. Define SI unit of force is very common. Do not say that SI unit of force is defined as 1 Newton. I have seen students writing that. Okay, so SI unit of force is if 1 Newton of force acting on an object of mass 1 kg, then it will produce an acceleration of 1 meter per second square. So force produces acceleration, so you have to mention 1 Newton of force acting on an 1 kg object produces 1 meter per second square acceleration. Next, mention any 3 methods of reducing friction. So lubrication: applying lubricants like oil, grease reduces friction. Polishing the surface, making the surfaces smoother by polishing also reduces the friction. Using ball bearings, replacing sliding friction with rolling friction by using ball bearings also reduces friction. That's why ball bearings are used in our bicycle, motorcycle, four-wheelers. All of them have ball bearings installed. Even our fans, they also have ball bearings. All rotating objects generally have a ball bearing installed because rotational friction is less than kinetic friction. So that's why we try to use ball bearings. Next, mention any 3 properties of elastic collision. In elastic collision, momentum of the system before and after the collision remains constant. The kinetic energy before and after the collision remains the same. Okay, so it is not 3 properties, it must be 2 properties. So kinetic energy is constant and momentum is constant. What about inelastic collision? If the same question is asked about inelastic collision. In inelastic collision, momentum is still conserved, but the kinetic energy is not conserved. Okay, momentum will be conserved, kinetic energy will not be conserved. So if you see a question based on non-elastic collision, don't be afraid, you can still answer it, right? Just remember that momentum is conserved always. Kinetic energy can be conserved, cannot be conserved. State and explain work energy theorem of constant force. Very important question. Okay, statement: the work done by a constant force on an object is equal to change in its kinetic energy. Okay, so if a force is acting on an object, and the work done by the force is given by OW, then the change in kinetic energy Kf minus Ki equals to W. This is the work done. Now we will also do the derivation in a 5-mark question. Okay, that is a 5-marker question. I am not doing the derivation as a 3-marker. Okay, but I will be doing the derivation of prove work energy principle, that we will be doing in our 5-marker question section. What is a Carnot engine? Name the working substance used inside it. A Carnot engine is an idealized heat engine that operates on the Carnot cycle and is the most efficient engine possible under the laws of thermodynamics. It consists of 4 reversible processes, 2 isothermal, that is constant temperature, and 2 adiabatic, no heat exchange. Okay, working substance in a Carnot engine is ideal gas. So this can be asked in as a MCQ question as well. So be careful. The working substance in a Carnot cycle, Carnot engine is ideal gas. Next, state and explain first law of thermodynamics. Statement: when heat Q is supplied to a system, part of this heat is used in increasing its internal energy and rest is used to perform the work on the surroundings. Okay, so if I give you some money to purchase something, what you will be doing? You will purchase some chocolates for yourself, and then with the remaining money you will purchase the items that I have asked for, right? So you have done this in the when you were a kid, right? So your father or your uncle gave you 20 rupees. Okay, go and bring me some oil from the shop, or bring some rice from the shop. What you do? Or bring some samosas from the shop. So what you do? You went to the shop. The samosa guy said that okay, each samosa is 6 rupees, so 18 rupees for 3 samosa. You buy 3 samosas, and using the remaining 2 rupees you buy some eclairs chocolate, right? So this all of us had done it in the past, right? So the energy that you give to a system, they also do it like that. Okay, some part is done to increase its internal energy, buying chocolate, and remaining amount is used for doing work. Okay, so if I give you some energy, the entire energy cannot be converted into work. Only some part will be converted into work, remaining part will be converted into its internal energy. The law is basically the law of energy of conservation applied to thermodynamical system. It states that energy cannot be created or destroyed, only transferred from converted from one to another. Okay, this last statement is not required, but you should mention that first law of thermodynamics is basically conservation of energy. Next, calculate the efficiency of a Carnot engine operating between 127 degrees Celsius and 27 degrees Celsius. So efficiency of a Carnot engine is given by 1 minus T2 by T1. Here T2 is 27 degrees Celsius, that is 27 plus 273, that is 300 Kelvin. Don't put the value directly, you have to convert it into Kelvin temperature, whereas T1 is given by 127 plus 273, that is 400 Kelvin. Okay, so eta, that is efficiency, is 1 minus 300 divided by 400, that is 1 minus 3 by 4, that is 1 by 4, that is 0.25 or 25%. Okay, so efficiency of a Carnot engine is 25%. Next, moon has no atmosphere. Why? The moon has no atmosphere because its gravitational force is very weak and low escape speed of the gases. Okay, so because of the low gravitational force, escape speed is also low for all the gas molecules. Since the moon's mass is very small, it cannot hold the gases around it as they escape into space due to low gravity. Okay, so low escape speed and RMS speed of the gas molecules are higher than its escape speed, so gas molecules escape to the what should I say, escape into space. Next, state and explain Newton's law of gravitation, another very important question. Newton's law of gravitation states that every object in the universe attracts each other. Every object in the universe attracts each other. Objects with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between the masses. Okay, next, mathematical form F is equal to G m1 m2 by r square. F is gravitational force between the bodies, m1 m2 are mass of the two bodies, small r is the distance between their centers, G is universal gravitational constant. Suppose we have two masses, okay, the distance between their centers is small r, this one is m1, this one is m2, okay, the gravitational force between these two masses is given by this simple easy formula. Now let's move on. State the three Kepler's law of planetary motion. Sometimes it can be asked all three, sometimes they will ask you only the third law. Third law is more important. Kepler's first law, every planet moves in an elliptical orbit around the sun with the sun at one of its foci of the ellipse. Okay, foci is the, because ellipse has two focuses. Focuses is wrong, okay. The plural form of focus is foci, okay. So foci means more than one focus. Kepler's second law, law of ABHYAS, a line segment joining a planet and sun sweeps out equal areas in equal interval of time. Okay, this is called law of ABHYAS. Kepler's third law, law of periods. The sequence of the orbital period t of a planet is directly proportional to the cube of the semi-major axis small r of the orbit. So Kepler's law states that each planet is basically orbiting in an elliptical orbit, okay, and the sun is located in one of the foci. So this distance is called semi-major axis. This is semi-major axis, okay, from the focus, not the distance from the focus but from the center, okay. This distance is called semi-major axis, okay. So t square is proportional to r cube, okay. Next, derive the relationship between small g and capital G. Very interesting. Suppose we have an object. We have our Earth. Okay, so mass of the Earth is, say, capital M. Okay, and the radius of Earth is given as capital R. Okay, now assume that the object is resting on the Earth itself. Okay, I am not drawing it because I have to draw some vectors, so that's why. So the object rests itself on the surface of the Earth. So at this case, what will be the distance of the object from the center of the Earth? That distance will again be capital R. Now what will be the gravitational force according to universal law of gravitation between this small mass m and Earth? The force from law of gravitation is given by G capital M small m by r square. This is according to the Newton's law of gravitation. But we also know that the force can be represented using a simple weight of the object, which is given by mg. Okay, the same force is actually the weight of the object, which is mg. So these two must be equal. Two forces cannot be different. Okay, the same force acting on the mass, and weight of the body is basically due to the gravitational universal law of gravitation, right? So we can say that mg is actually equals to gmm by r square. So m cancels and we say g equals to gm upon r square. So this is the relationship between g and small g and capital G, younger brother and big brother. Okay, so small g equals to capital Gm by r square. Now next, assuming the expression of orbital velocity of a satellite at height capital small h, derive an expression for time period. So suppose this is our Earth. Okay, a satellite is orbiting around the Earth. Okay, the radius of the Earth is r and the height of the satellite from Earth is small h. So what is the total distance? Total distance must be r plus h. Okay. So when a satellite orbits around Earth, okay, its velocity you have to remember, which is given by square root of gm by r plus h. There is a way that you can even derive this expression as well. So for that you have to calculate the centripetal force required by this satellite to orbit around Earth. The centripetal force is given by m v square by r plus h. And this centripetal force always has to be provided by some other force, okay? So here centripetal force is provided by the universal gravitational force. So that is g m, mass of the satellite says small m divided by r plus h whole square. So from this comparison also you can calculate the velocity. Okay, centripetal force and the gravitational force must be same. Okay, so because centripetal force, whenever if you want to rotate in a circular motion, you will need a centripetal force acting on you. Now it can be provided by multiple things, and for a satellite there are no multiple things, only one force that can provide, because satellite is rotating around the Earth, right? So it is no longer require a rocket. The rocket is there, but it is not the major force that is driving it. It is basically in a free fall state. It is constantly falling, okay, trying to fall on the surface of the Earth. It is not able to do that, okay, and that is why this velocity is generally constant for a given satellite at a particular height. G is constant, m is constant, r is constant. So if you keep the height constant, the velocity will also be constant. Okay, now they asked you calculate the time period t. So if you know this total path distance, if you know the total path distance, say the path distance is s, okay, total path is s, then time period will be nothing but s divided by velocity, distance by speed. That is the time, right? Time required to rotate once. So what is this distance? To find the distance, we will use again geometry, not physics but geometry. This is a circular path. So for circular path, what is the distance? Distance is perimeter. So what is the perimeter of a circle? Perimeter of a circle is 2 pi r. Here it will be r plus h. Okay, so the total path traveled by the satellite in one rotation is the perimeter of its trajectory, that is given by 2 pi r plus h, because the radius of the circle is r plus h. So now we will put these values. So 2 pi r plus h divided by square root of gm by r plus h. So now it will be 2 pi r plus h into square root of r plus h divided by gm. Okay, so it was in division, so that's why it's rotated. So time period is given by 2 pi square root of r plus h whole cube divided by gm. Okay, so what we have done, we have incorporated this r plus h inside the square root, okay, and that's why it becomes cube. So if you take a number and put it inside a cube, square root, it becomes square, right? So square into r plus h square into r plus h is r plus h whole cube. Now let's move on. Define stress and strain, mention its SI unit. Stress is the restoring force developed per unit area inside a body when an external force is applied to deform it. Its SI unit is Newton per meter square, and stress is given by force per area. Okay, so stress is the restoring force developed per unit area inside a body when an external force is applied to deform it. So if you try to deform it, the body will try to resist it, and that force is called stress. Strain is the ratio of change in its dimension, length, volume, etc. of a body to its original dimension when the deforming force is applied. Strain is a dimensionless quantity. Strain is a dimensionless quantity. Okay, stress is proportional to strain. From there you can also calculate the proportionality constant, which is Young's modulus for longitudinal stress by longitudinal strain. Define number 1 Young's modulus, number 2 rigidity modulus, and number 3 bulk modulus. Okay, Young's modulus is defined as the ratio of longitudinal stress to longitudinal strain within the elastic limit. So Y is longitudinal stress divided by longitudinal strain. Rigidity modulus is given by shear stress by shear strain, and bulk modulus is pressure or volumetric stress divided by volumetric strain. Okay, so change in volume divided by volume stress divided by change in volume divided by original volume, that is volume strain. Okay, now let's move on. Define Poisson ratio, give limit for it. Okay, Poisson ratio is defined as the ratio of lateral strain to longitudinal strain in a stressed compressed body. So when you are applying some twisting, basically it happens when you are twisting an object, okay, then the lateral strain by longitudinal strain. So there is a lateral strain. Lateral strain means, for example, if you have a book, if you apply some parallel force to it, the book deforms some weird way, right? That is called lateral strain. And lateral strain by longitudinal strain is called Poisson ratio. The limit of Poisson ratio is between 0 to 0.5. It cannot be less than 0, it cannot be greater than 0.5 as well. Okay, again the Poisson ratio is a dimensionless quantity. Next, state and explain Hooke's law. Hooke's law states that within the elastic limit, the stress produced in a body is directly proportional to the strain produced, that is stress proportional to strain, or stress equals to Young's modulus into strain, where Y is modulus of elasticity, Young's modulus, shear modulus or bulk modulus depending upon the type of the deformation. Next, derive an expression for elastic potential energy in a stressed wire. This is also very important. The derivation, small 3 marks derivation. So here we have a wire. Okay, suppose we have a wire which is hanging and you applied some force at this end to extend it. Okay, and because of this force the wire extends by a small length, say delta L. The original length was L, now the wire extended by a length of delta L. Now first of all, so original length was L. Okay, now you have to find the potential energy. Before going into that, we have to calculate this force in terms of Young's modulus. That is step number 1. So we know that Young's modulus is given by stress by strain. Practice it, it is very easy derivation and very common derivation. Stress is given by force divided by area and strain is delta L divided by L. Okay, this is the mathematical term. Nowadays students used to remember mathematics better. So F by A divided by delta L by L. So if you can calculate F from this, we get F equals to YA delta L by L. Okay, just cross multiply, you will get it. Force is YA delta L into L. Done. This portion is done. Next we have to find the work that is being done by this force. For that you have to calculate the average force. Okay, why average force? The force is not constant throughout the length of the wire. So if you see at the end, here the wire is fixed. Here the wire is fixed. This is tied at this point. So here the force is 0. And at this end force is maximum, which is F. So what is average force? Average force is the force at this end, okay, plus force at this end plus force at the other end, that is 0 divided by 2. Simple average, okay. You can use integration method as well, but we are not doing it. So the average force here is F by 2. Okay, so average force here is F by 2. Now what is the work done? The work done is given by F average into displacement. So because you applied this force, average force, the wire extended by a small distance delta L. Okay, now this delta L, even though we are measuring it here, it can happen, some part will happen here, some part will happen over here. So this is the overall change in length. So don't say that, sir, force is applied over here, delta L is over here, so why we need to take average? Because average, this change in delta L can happen anywhere. Okay, so F average into delta L. So what is F average? F average is F by 2 into delta L. Now this is not over, you have to put this value of force in this equation. So half into Y A delta L by L into delta L. So the average work done is half into Y A by L into delta L square. This is the work done, and the same will be stored as the energy. The same will be stored as energy. Okay, so this is the energy stored inside the elastic potential energy stored in a stressed wire. Okay, not super difficult derivation. This is a 3-mark derivation. Okay, if you practice it, you will get this as a common question. Next, state and explain Pascal's law. Statement: Pascal's law states that when pressure is applied to a confined incompressible fluid, the pressure is transmitted equally and undiminished in all directions throughout the fluid. Explanation: consider a fluid completely enclosed in a container like a hydraulic system. When an external pressure is applied at any point, the fluid transmits this pressure uniformly to all parts of the container and to the walls. This means that at every point fluid experiences the same increase in pressure. So if you apply a pressure in one area of a fluid, the pressure is extended to all parts of the fluid. Right? Next, mention any two factors on which pressure inside a fluid depends. Pressure inside the fluid depends on depth. Pressure increases with the depth increase below the surface of the fluid. Density of the fluid, okay, denser the fluid exerts more pressure at the depth. So we know that pressure is rho d h. Okay, rho is the density of the fluid, d is depth. Okay, sorry, it is not rho dh, it is rho gh. Okay, g is the gravitational acceleration, h is the depth of the liquid. Okay, so more the depth, more will be pressure, more the density, more will be the pressure. And gravitational acceleration is normally varies very less unless and until you are going outside into space. Okay, so based on that can change, but normally if it is you are considering on the surface of that earth, the variation is very small, so you can say that g is almost constant. Next, now derive an expression for gauge pressure inside a static fluid. Might seem like a difficult question, but actually it is very easy, and the derivation you have done in your childhood days. So here we have a liquid inside a container, and we are suppose the liquid is like this, and we are trying to find the pressure at this point P. So gauge pressure is nothing but simple pressure due to the liquid. Okay, so we have to find the pressure, the depth of the liquid, say h. Okay, h is the depth. Even though we are saying depth, I am using h. Now how to find the gauge pressure? So for that you have to consider a cylindrical column of the liquid which extend from this point till the top. Okay, so suppose the area of this cylinder is A. Area is A. Okay, depth is h. Now what is the volume of this cylinder? The volume of this cylinder is given by area into h. Okay, volume is area into h. Now if you know the volume, you can also calculate the mass. Mass is given by volume into density. The density of the liquid is rho. Okay, so volume into density is mass. Now what is the weight that liquid exerts at this surface? The weight or the force the liquid exerts, is given by m into g, right? M into g, the weight of the liquid column that exerts at this point on all the points on this surface, right? So from here we can even calculate the pressure, gauge pressure, or say Pg. It is given by force divided by area. Pressure is force divided by area. So M is V into rho, and here we have G, so it is mg by area. Okay, so now put the value of M, V rho by G by area. Now put the value of V, which is A into H into rho into G divided by area. So area cancels, we get H rho G. So this is the expression for gauge pressure. Very easy derivation, nothing difficult. Okay, next, derive the equation of continuity. What is the significance of this equation? Obviously, when we are deriving the equation of continuity, significance has to come. Now in this case you have to draw some weird diagram like this. Okay, suppose we have a pipe of water pipe. Pipe is carrying some water inside it. Okay, the velocity of water at this is V1, and the with which it is coming out is V2. The area here is A1, area here is A2. Okay, now what is the volume of liquid? Volume of liquid that travels through this. What is the volume of the liquid that travels through this point? The volume of liquid, say for a time duration delta t, is given by the volume of the liquid that is traveling for a time delta t is given by the area. So in delta t time, the liquid that is entering, that must have moved up to this distance, and that if you can calculate the volume, that will give you the volume, that is A1 into velocity 1 into delta t. That is the volume of liquid which is entering the pipe. So say this is V1. Okay, so volume of the fluid which is entering. Now what is the mass of the fluid? Mass is volume into density. Now density, same liquid is flowing, so density is constant, right? So volume into density is the mass. So that will be A1 V1 delta T into rho. Right? You have to do it for only once. Next, the mass of fluid which is coming out of the pipe, the mass, this is the mass which is going in. Mass of the fluid which is coming out of the pipe, that is basically same V2 rho, and it should be A2 V2. Time should be same, obviously, right? Same in the same time. So A2 V2 delta T into rho. Now we know that mass is conserved, right? So whatever mass enter the pipe, the same amount of mass should exit the pipe as well. Okay, so from there we can say mass M1 must be equals to mass M2 because mass is conserved. So from there we can say A1 V1 delta T rho equals to A2 V2 delta T into rho. Now rho delta T cancels and we get A1 V1 equals to A2 V2. This is the equation of continuity. And as I mentioned, this the significance of this equation is it represents conservation of mass. This represents conservation of mass. You may not understand exactly only if you look into this equation, but if you do the derivation, then obviously this formula is coming from the conservation of mass principle. Now next, write any two applications of Bernoulli's principle. lift on an aeroplane wing. Air moves faster over the curved upper surface of the wing and slower below it. The pressure difference produces an upward lift, helping the airplane to fly. Perfume sprayer, when air is blown through a narrow tube, its speed increases and pressure decreases. This low pressure sucks the liquid up from the bottle and sprays out the fine droplets. So these are the two applications of Bernoulli's principle. Next, write any two differences between heat and temperature. Heat is the form of energy transformed between bodies due to temperature difference. Temperature is the measure of hotness or coldness of a body. SI unit of heat is joules. SI unit of temperature is Kelvin. Next, what is meant by anomalous expansion of water? The temperature, the property of which by which it contracts on heating from property of water, by which it contracts on heating from 0 to 4 degrees Celsius and expands on cooling from 4 degree to 0 degree Celsius is called anomalous expansion of water. Normally, what happens if you increase the temperature, its volume decreases. Okay, if you increase a liquid, its volume generally increases, right? But for water, what happens as you increase the temperature from 0 to 4 degrees Celsius, its volume decreases. Okay, so this is the 4 degrees Celsius. At 4 degrees Celsius, the volume of water is maximum. The density of water is maximum. And that is why it is called anomalous expansion of water. In nature, except water, all other objects, natural objects I am talking about, in nature except water, all objects, if you heat, the object will expand, the volume will expand. Okay, the density will decrease, except for water. Water is a miraculous creation of nature, where if you increase the temperature up to 4 degrees Celsius, what happens? Its volume decreases, density increases. Around 4 degrees Celsius, the density is almost equals to 1. And again, if you start increasing the temperature from 4 degrees Celsius, it behaves like all other natural objects. But from 0 to 4, from 0 degrees Celsius to 4 degrees Celsius, the behavior of water is completely different, not expected. That's why it is called anomalous. Anomalous means which is weird, which is not according to the common observation. That's why it is called anomalous expansion of water. And that is actually a main reason that life exists under the ocean, even in the Arctic region, when all water freezes on the top, the water below still remains water, and the animal life survives under it. Okay, that is one of the beautiful invention of nature. Next, derive alpha V equals to 1 by T for an ideal gas where the symbols have their usual meaning. Alpha V means coefficient of volume expansion. Coefficient of volume expansion. So we have to find alpha V, and we have to see that why it is 1 by T. Now, alpha V is given by 1 by V dV by dt. Okay, at constant volume, obviously. So alpha V means the coefficient of volume expansion, and for that, obviously, if you increase the temperature of an ideal gas, okay, its volume increases. So this is the change in volume with respect to temperature, and this is the original volume. So if you divide this, then you will get dV by dt at 1 by V. Now, we have to show that is equals to 1 by T. How to do that? You have to first of all remember the definition. If you remember the definition, everything is very easy. We know that PV equals to nRT or mu RT. Okay, mu RT. Let me write mu RT. Okay, so now, V is actually equals to mu R T by P. Okay, actually when you are changing the volume cannot be constant, but pressure should be constant. Okay, pressure should be constant. Now differentiation, those who have learned it, very good. Those who have not, you should go and check some of the Ankit Sir classes. So change in volume, if you differentiate both sides, dV by dt. Now mu is constant, R is constant, and for this particular case pressure is also constant, so we get dt by dt. Okay, so dt by dt is obviously 1, so we get dV by dt equals to mu R by P. Okay, mu R by P. dV by dt at constant pressure is basically mu R by P. So let's put that value over here. So alpha V equals to mu R by P into 1 by V, or mu R divided by PV. Okay, so alpha V equals to mu R divided by R into T, mu R into T, because PV equals to mu RT. So mu R cancels and we get 1 by T. So alpha V is actually equals to 1 by T. So volume coefficient of gas is basically 1 upon its absolute temperature. Okay, easy derivation. Let's move on. Mention any 3 properties of thermal radiation. Thermal radiation does not require a medium for propagation. It can travel through vacuum, that is heat from the sun reaches earth. Thermal radiation travels in straight lines just like light waves. All bodies emit thermal radiation and the amount of emitted energy increases with the temperature. Clear? Next, give positions at which the potential energy of a particle executing SHM will be maximum and 0. So potential energy is maximum at 2 extreme position, okay, x equal to plus minus a, and is 0 at the mean position. About kinetic energy is 0. Kinetic energy is 0 at extreme position and kinetic energy is maximum, okay, at mean position. So if the same question is asked about kinetic energy, then you should know. So you should remember one question and prepare for another question. Okay, so it will be exactly opposite for kinetic energy. Potential energy maximum at extreme position, okay, and minimum at mean position. Kinetic energy minimum at extreme position and maximum at mean position. Next, mention the expression for the period of oscillation of a spring and explain the terms. The spring mass system, the expression is T equals to 2 pi square root of m by k. T is time period, m is mass of the spring, mass attached to the spring, k is the spring constant in Newton per meter, and pi is obviously the constant. Next, mention the expression for time period of oscillation of a spring and explain the terms. This is not a spring, sorry, this is for a pendulum. Okay, the time period of oscillation of a simple pendulum is given by T is equal to 2 pi root of square root of L by G. The time period of oscillation in seconds, L is length of the simple pendulum measured from the point of the suspension to the center of the bob. Acceleration due to gravity, and pi is 3.14. Write Newton's formula for speed of sound in air. Explain why and how Laplace modified the Newton's law in speed of sound. Now this can be coming as a 5-mark question as well, but anyway, I have included it as a 3-marker question. Newton assumed that sound, this is also very important question by the way, in a 5-marker or 3-marker, this is also a very important question. Newton assumed that sound wave travels in isothermal conditions, that is V is equal to square root of P by rho. V is speed of sound in air, P is atmospheric pressure, rho is density of air. But if you calculate mathematically, this comes around 280 meter per second, whereas experimental measurement shows the value is around 332 meter per second. According to Laplace, the sound wave compress and expand rapidly, meaning that heat exchange does not have enough time to occur. Instead of isothermal process, the sound wave propagation follows an adiabatic process, that is no heat exchange. So he modified this formula as gamma P by rho, which turns out to be approximately 331 meter per second. Okay, for air it is approximately 1.4. If you put the value, okay, you will get this value 340 actually he get, but it is very close than Newton's value. Okay, Newton's value is far off, this value is much closer than the actual value. So that's why Laplace actually was correct, not Newton. So Newton sometimes can be wrong as well. Next, distinguish between longitudinal and transverse waves. Longitudinal waves, particles of the medium vibrate parallel to the direction of wave propagation, consist of compression and rarefaction. Example, sound waves in air. Transverse wave, particles vibrate perpendicular to the direction of motion, consist of crest and troughs. Example, waves in a straight string, water waves, etc. Next, mention the relation between wave frequency, wavelength and velocity. The relationship between wave velocity, frequency and wavelength is v is equal to f lambda. V is wave velocity, f is frequency, and lambda is wavelength. Right, now in this lecture you may have seen I have not discussed any questions from the chapter System of Particles and Rotational Motion, specifically because the student find that chapter little difficult. Okay, unless you are studying from a long time from the beginning, then you might find that chapter easy. Otherwise student find that chapter little tricky, and that's why I have ignored 2-3 marker, and also I will ignore for 5 marker question from that chapter. You can skip one chapter if you wish to. If you study all the 50 questions, definitely 10 questions you will be able to answer. More than 10 questions you will be able to answer, that is my guarantee. So with this guarantee I will be back with 5 marker questions. Again, if you study all those 5 marker questions, including I will also give you some example 5 marker numerical questions as well. So with that guarantee I will be back. Till then, bye. But it is not over yet. You have to watch my 5 marker video as well. And again, I request you to join the WhatsApp channel to download the PDF of